Hi, Algebra. This is our second section in Chapter 4 of our notes, and we're going to focus on two formulas today. So one of them is the slope-intercept formula, and that should look familiar from pre-algebra. So as a little reminder, in this formula, M represents our slope, and B represents our y-intercept, or that line crosses the y-axis. So we'll start with that formula, and we're going to write equations of the lines when we're given points and we're given slope. Okay, so in the first example, we're given this ordered pair that the line goes through. And we're going to start with slope-intercept form. Ignore that bell. Y equals mx plus b. So we're going to start by filling in these numbers. So the y value is 3. The slope is 9. The x is -1. And then plus b. So 3 equals -9. Plus b. So what we're doing is solving for b. I should have put that the slope was 9 right away. Now to get b alone, we need to get rid of that -9. So that means the value of b is 12. So now I'm going to plug those numbers into the formula. Y equals 9x plus 12. I'm going to have you do this one on your own using the same process. Now, on these next two, I'm going to review with you something from 7th grade or pre-algebra, and it's a little mnemonic device when we have lines that aren't typical in slope-intercept form. So I'm going to start with HOY. You might hear me say, or your teacher say, hoy. And that means the line is horizontal, which means it goes from the left to the right. The O means that it is, the slope is 0. So that would be m equals 0. And the Y means that the equation is in the form of y equals. So for example, you might see something like y equals 2. And the equation, or I'm sorry, the graph for this would look like a horizontal line through the y-axis at 2. Our other scenario, VUX, is a vertical line. So that means it runs up and down. U stands for undefined slope. So we can't use a number for that. And the equation is in the form of x equals. So for example, we would see something like x equals -1. In a graph like this, we would have a vertical line through the x-axis at -1. I did not do a good job drawing that line through -1, but you get it. So when we look at these next two on the bottom of that chart or that box, we're first told that our slope is 0. So I'm going to start with my formula, and I like to write it every time so I know where I'm filling in and that I'm filling things in the right spot. I'm going to put a -8 in for x and a 6 in for y. So 6 equals 0 in for the slope times -8 there's another bell, times negative 8, and I'm going to find b. So this means 6 equals 0 times the number is just 0 plus b. So 0 plus a number to make 6, b equals 6. I'm going to fill in this box over here that the slope is 0. That came from the given problem, and I found my b value was 6. And because the slope is 0, this is an HOY equals. So that equation is y equals 6. The next one, we're told that the slope is undefined, so I'll fill that in. That's a VUX problem. So I can just show that I can just use the x value and point out that the x value is negative 10. Oops, I messed that up. When the slope is undefined, its equation is an x equals equation. And this one, the x equals negative 10. A graphed version of this would look like this. We'd have a line over here. It would go through that point, so it has no y-intercept. That's what that 0 with a line through it represents, because it's not crossing the y-axis. Okay, this next section of notes, we're going to focus on the formula called point slope. And we use that when we are given points and given a slope. And really, we could have used it up top, but we're going to use it here. We needed to review slope-intercept form. So that formula is y minus y1 equals m times x minus x1. And we have to start on this next problem finding the slope. So we're going to use that old slope formula, y2 minus y1 over x2 minus x1. So I'm going to rewrite these ordered pairs, negative 3, negative 1, negative 2, 4. And the change in y is 4 minus negative 1. The change in x is negative 2 minus negative 3, which will give me, zoom in a little bit, 5 over 1. So I know my slope is 5. I don't need to put over 1. And now I will use point slope. Let's switch up some colors. So y minus y1 equals m times x minus x1. And I'm going to use that slope I found and use one of the ordered pairs. So I'm just going to circle that I'm using the first one. Y minus negative 1 equals 5 times x minus that x1 value, so negative 3. And now we're going to start to simplify. I'm going to move my work up here a little bit. Y plus 1 equals 5 times x plus 3. Okay, now we need to distribute. Y plus 1 equals 5x plus 15. And we're almost in slope-intercept form. We just have to get rid of this plus 1 next to the y, so we need to use our inverse operations. And that's y equals 5x plus 14. And really, since our ordered pairs were given to us in function notation, we can write this in function notation. F of x equals 5x plus 14. Remember that function notation doesn't change the operation behind that equal sign. It's just changing how we're writing it. Okay, we'll do this next one and then one more, and you'll finish on your own. So this next one we're given a graph. We need to find the slope, and I'm going to go using the slope-intercept process, or just the process of finding slope. To go from this point at 6, 9 to 8, 12, we're going up 3 and running 2. And I know that looks disproportionate, but just ignore that for now. So I found that my slope was 3/2, and then I'm going to use point slope because I don't have a y-intercept. So y2 minus y1. Nope, I messed that up. Sorry, guys. Y minus y1 equals m times x minus x1. And I will use the ordered pair. Let's use this ordered pair, 2, 3. So y minus 3 equals my slope, 3/2, times x minus, we'll use the x coordinate, 2. Y minus 3 equals 3/2 x minus 3. And now we want to get this y alone, so we have to get rid of that minus 3 on each side with addition. And that gives me y equals 3/2 x. Now there's no y-intercept there, so we can assume that if this line continued, it would go through the origin. All right, in this last section, we're going to look for, we're going to look at these data models and decide if they are linear or not. If possible, write a linear equation as a linear function. So we are looking for a constant rate of change. Okay, we're looking for a slope that is consistent. I hope this is still recording. Let's hope. Okay. Okay, so on these next ones, I'm looking at how these change. So this goes up by 2, up by 1, up by 1, up by 2. And this goes up by 50. This goes up by 25. This goes up by 25. And this one goes up by 50. So those ratios, change in y over the change in x, we go up by 50 over 2, which simplifies to 25 over 1, and that's consistent across the table. So that means this is a linear function. My slope is 25, and from the table, I can find that my y-intercept, when x is 0, y is negative 35, so my equation would be y equals 25x minus 35. If we need function notation, f of x equals 25x minus 35. Try that last one on your own.